All right, welcome everyone. Here is a 14.5 exam question. We're here in an exam from fall 2015. This is problem number 11. Remember, 14.5 covers the chain rule. So we're interested in the chain rule here. So we'd like to calculate or use the chain rule from Calculus 3 to calculate the partial derivative of w with respect to s. No credit for any other method. So maybe the first thing that I want to do here is maybe draw a little tree diagram. So I'm taking the partial derivative with respect to s of w. So I'm starting off with w here. It looks like w has x's, y's, and z's in it. So here's x's, y's, and z's. And I'm drawing this little tree diagram as we brought up in class. It looks like x has s's and t's in it. So s's and t's. Y has just t's. And z has just s's. So remember, I want to go down all the paths that lead to s's, right? So in this case, I want to do the partial of w with respect to x, and then the partial of x with respect to s. If you would try to go down this path, right, you would multiply by 0, because when you take the partial derivative of this with respect to s, you get out 0. So notice we don't have anything there. And I'm going to do the partial derivative of w with respect to z, and then z with respect to s. So those are going to be the paths that I'm using in this case. Let's go ahead and write that down. I'm going to do w with respect to x times x with respect to s plus, then I'm going to do w with respect to z times z with respect to s. And that is going to give me this partial derivative of w with respect to s. All right, so let's go ahead and do it here. So w with respect to x. So that looks like 2xz, and let's see, there's no x's there, so forget about that, times x with respect to s. So x with respect to s, that's just going to give me out a t, okay, plus w with respect to z. So that's going to give me x squared, and let's see, there's a z over here, so that's going to be plus y e to the z. And remember, all of that right there is w with respect to z. And then finally, z with respect to s. So here's my z with respect to s. That's going to be 1 over s in this case. All right, let's go ahead and simplify a little bit. Notice usually you do your dependent variables and everything, in terms of your independent variables. Remember, here are our independent variables, here are our intermediate variables, and here is our dependent variable. So I'd like to have everything with s's and t's in it. So that is here, I'm going to do 2, and instead of x, I'm going to write st. Instead of z here, I'm going to write the natural log of s, and then there's the t. That's already an independent variable. And then plus, instead of x, I'm going to write st, and that's all squared, it looks like, plus y. Y in this case is t squared, and e to the z. So e to the z, z is the natural log of s, and then I'm multiplying that by 1 over s. I can simplify this one more time here. So this looks like 2s t squared, the natural log of s, plus, and now, right, this little 2 would distribute to each piece. So that's going to be s squared t squared plus t squared, and we have e to the natural log of s. Well, luckily these are inverses, so they'll perfectly cancel out. And now I'm dividing by s for these terms right here. Right? I'd be dividing by s, so there's actually a little bit more cancellation here. And let me just go ahead and erase those. Right? So divide by s, and there we go. So this is our result. This is our final answer here for part A. So the partial derivative of w with respect to s, fully simplified and with just our independent variables. Now that we have that, we can go ahead and use it for something, right? So in this case, it says find the partial of w with respect to s when s equals 1 and t equals 1. So, okay, so right, I have a lot of this work already done. Now I just need to plug in 1 everywhere I see an s and 1 everywhere I see a t. So let's see, 2 times 1 squared times the natural log of 1 plus 1 times 1 squared plus 1 squared. So luckily the natural log of 1 is just 0. So plus 1 plus 1. So my final answer in this case is a nice clean 2. All right, and that's all there is to it. That's a problem from 14.5, the chain rule here in Calc 3. I hope you guys enjoyed. Good luck on the upcoming exam and everything. I'll see you out there.